square roots. Now we're going to be taking square roots, but this is why we needed to simplify, is because we have to add and subtract like square roots, kind of like when we had like terms. So we're going to kind of do like a flashback Friday for a moment. We're going to think back to when we combined like terms, how that worked. So before, we had something that would look like, so for example 1, we would have something that looked like 3x plus 7y minus 6x. And we would need to simplify that. So which parts would we end up being put together? The x's. Good. So we would do 3x minus 6x and then do a plus 7y. And what is 3x minus 6x? Yeah, 3 minus 6 is, or 6 minus 3 would be 3. And then positive or negative if I'm doing a small minus a big. Negative. So negative 3x plus 7y. Kind of remembering it a little bit? Okay, so if you want to grab a highlighter, you can, and you can highlight those like terms, the 3x and the negative 6x. That was kind of our big thing here. Here it is. All right, so today what we're going to do, I'm going to do is like a little arrow to show that we're moving on for today. Today, instead of x's and y's, we're going to have square roots. So let's say instead of 3x, we have 3 times the square root of 5. And then instead of plus 7y, we have plus 7 square roots of 2 minus 6 square root of 5. So when we combine square roots, it's really just combining like terms. So we can only combine square roots that have the same square root simplified with it. So what square roots match here? 5 and square root of 5, square root of 5. So we would do it exactly the same. We probably would skip this next step where we rewrite it next to each other. But I would do 3 square root of 5 minus 6 square root of 5 plus 7 square roots of 2. Because really what we're doing with those numbers, those coefficients, the numbers in front of the square root, is we're counting how many of those square roots we have. We have 3 square roots of 5. So square root of 5, square root of 5, square root of 5. And then we're taking away 6 square roots of 5. So if I have 3 take away 6, what's 3 minus 6? Negative 3, as we already said. We keep the square root of 5 just as it is. And then plus 7 square root of 2. So really just the same thing that we've done before with x's and y's, but now we're doing it with square roots. All right, we have 4 problems total today. We just did 1. All right, number 2. We're going to do another kind of easier problem, and then we're going to start thinking a little bit more complex. So number 2, we have 6 square root of 3 minus square root of 3 plus 10 square root of 3. Okay, and again, we're literally just counting. So, do I have like square roots? Yep. Up to your mind, put your phone away. Focus. All right, So we have square root of 3. They're all square root of 3. So we're going to combine all of them, and when we add and subtract, we go left to right. So we're just going to start with 6 square roots of 3 minus square root of 3. How many is that for a square root of 3? What's my coefficient if I don't see it? 1. So 6 minus 1. What? 6 minus 1? 5. There you go. So 5 square root of 3 plus 10 square roots of 3. And 5 square roots of 3 plus 10 square roots of 3. How many square roots of 3 would that end up being? 15. So really it's just about adding our coefficients today and subtracting our coefficients. But then we start getting into a problem that's a little bit different, but a little bit the same. We only have 2 more problems left. You guys are crushing it. You're doing great. Amazing. You got this. All right, number 3. Number 3, we have 7 square root of 3 minus 3 square root of 28 plus 4 square root of 7. So what's our issue with this one? Yeah, none of the square roots are the same. We have 3, 28, and 7. But there is a way to simplify this. Before we start simplifying it, we need to decide, are these all simplified square roots? So can I break 3 up into anything else? Nope. Can I break up 7 into anything else? What about 28? Yeah, if I go back to my perfect squares, okay, we're going to start at 25. So in our calculator, we do 28 divided by 25. See if that works. Some of you should be able to find that answer without having to do the dividing, but that's okay if you do. 28 divided by 25, we get a decimal. No good. So then we do 16. No good. 9. No good. 4. Yep, it's 4 and 7. So as we take a look at that, we're going to take this 28, we're going to break it up into the square root of 4 and the square root of 7. Okay, that negative 3 still has to stay on the outside. It's still negative 3 times that. So if you wanted to use a different color highlighter to kind of highlight this 28 was the problem before we started, you could say that that's what we're going to think about first. Okay, and the reason why we used our pink sheet is because now we know the square root of 4. What is the square root of 4? 2. When we find the square root, we no longer use that root sign, that radical sign. It's just 2. Do we know the square root of 7? Nope, so that stays square root of 7. So negative 3 times 2. Negative 6. Square root of 7. And you're like, cool, we did a problem. We're done. You're right, we did do a problem, but this problem is a problem within a problem. So I'm going to go back to my original, and I'm just going to rewrite it down here as what it was. It was 7 square root of 3. But now instead of minus 3 square root of 28, it's minus 6 square root of 7 is what that turned into. And then I had a plus 4 square root of 7. So we just simplified that inside amount. And now that we simplified it, do we have any parts that we can combine? Yeah, the square roots of 7. So if you want to go back to that other highlighter, you can show that we're combining those 7s. When we combine negative 6 square root of 7 and 4 square root of 7, the only things that we're actually putting together are the coefficients, the numbers on the outside. So we're just thinking, what's negative 6 plus 4. Negative 2. So if you need to add that as a side comment, that we're adding just the outside numbers, add, subtract outside numbers, you can put that there. You don't have to. But sometimes when you look back, we're like, how the heck did we get negative 2? It's that we're adding and subtracting those outside numbers, those coefficients. All right, we have one more problem. Number 4. All right, number 4, we have 6 square root of 2. Plus 9 square root of 392. Oh, cool. Plus negative 2 square root of 32. All right, so as we take a look at this one, square root of 2, we can't divide that by anything. The only thing smaller than 2 in those square roots is 1, and that won't help us, in case you didn't know that. Okay, so 392, let's see if we can divide 392 by something. So I'm going to throw that in my calculator. 392 divided by, what's the biggest number before we go over 392? Cool. 361. So we divide by 361, just double check. Nope. Okay, so then we just work our way up. So 324. Nope, we get a decimal. 289. Nope, we get a decimal. 256. Nope. 225. Nope. 196. Ooh. Yep, 196 works. 196 and 2. So we're going to split that up into 2 square roots. The square root of 196 and the square root of 2. So we're going to do 9 times the square root of 196 times the square root of 2. So when we did 392 divided by 196, our answer was 2. And we got 196 from that pink sheet. So what is the square root of 196? 14. How did you know? Yeah, it's like on the pink sheet. That's why we use the pink sheet. Square root of 196 is 14. So we have 9 times 14. I don't know that answer. 9 times 14. I suppose you could do 10 times 14 is 140. And let's subtract 14. We get 126. So 126 square root of 2. All right, before we keep going, we do need to double check if we can simplify other square roots. We can't simplify square root of 2. Now we have square root of 2, so we're done. What about 32? Is there something I can divide 32 by? Okay, let's start with 25. Can we do 32 divided by 25? Nope. 32 divided by 16? Yep, we get 2. So we'll do square root of 16 and square root of 2. Well, what's really important today is that there's already a coefficient. So that negative 2, I've kind of been doing this without saying it. That negative 2 has to stay there. So negative 2 square root of 16 square root of 2. If you use the square root of 4, that would be fine. You could do 4 times 8, but then you'd have to break up 8 into 4 times 2. You'd have to do it again. So to keep it simple, we want to use the biggest number. So negative 2, or sorry, what's the square root of 16? 4. So negative 2 times 4 times the square root of 2. And then negative 2 times 4 is negative 8, square root of 2. So I'm going to take this problem, I'm going to just rewrite it out so I have all my answers out. We have 6, square root of 2 is what we started with, plus, and then instead of 9 square root of 392, we simplified that to 126 square root of 2. And then instead of negative 2 square root of 32, we simplified that to negative 8 square root of 2. So really what we're doing here is they all have square roots of 2. What? Not 32. Why don't you guys yell at me? Square root of 2. All right, they all have square roots of 2. So because they all have square roots of 2, we can combine them all. So really what we're thinking is what is 6 plus 126 plus negative 8? If you want to write that kind of in light color or light pencil shade so you can see that that's what we're thinking. And we do 6 plus 126 plus negative 8. And our answer is 124. So we can just write it as 124 square root of 2. Okay, we're just combining those coefficients. How are we feeling? Make sense? A little bit? Okay. We are not going to do a quick check.